Today we will discuss about a topic that is graph in chemical bonding. Okay, this is a topic that is present in chemical bonding chapter, where there is a graph that is drawn between potential energy of the atoms versus the internuclear distance. Okay, the distance between those two atoms. So on x-axis, what we have taken distance between the atoms. Like for example, they are very, very far away. Like let us suppose this distance is very far away. They are very far away. So the distance would be somewhere around, let us assume it would be, if this is 0, this is 74 picometer length, and this is somewhere around, let us assume 100. This is 200. Okay, let us write something like this: 100, 200 picometers, 400 picometers, like that. We are taking on x-axis. Okay. Now, on y-axis, we have recorded the potential energy of the system. Now, in this is whenever zero potential energy, here it is positive and here it is negative. Negative y-axis may we'll have negative potential energy. Positive y-axis may we have positive potential energy. Okay. So now when the two hydrogen atoms, these want to have a bond. Okay. Though they want to have a bond, they are coming closer. In the first case, when we observe, they are far apart. Like the distance between them is somewhere around nearly 200 picometers. Let us assume nearly 200 picometers. They don't know that these two exist. So what happens? The potential energy of the system would be 0. That's the reason why this dotted line is representing the potential energy of the system when they are at this point. Okay, when they are 200 picometer, the potential energy is 0. Slowly, they want to form a bond. They are coming closer. So now when they are coming closer, the internuclear distance is decreasing. At 100 picometers, it is little bit just like minus 0.1 or whatever. There is some kind of, when the 100 picometer, it is little bit decreasing. The potential energy is decreasing. Slowly, as they are coming closer, the potential energy is continuously decreasing. At this point, when they are at 74 picometer distance, that is the internuclear distance. That means these two hydrogen bonds have come so much close that their internuclear distance, this distance is how much? 74 picometers. They have minimum potential energy. Let us assume a hypothetical number. This is not correct. So hypothetical number, let us assume it to be somewhere around minus 20. Okay. So that is the place where they have minimum potential energy. So now these hydrogens, always anything in this world wants to be at minimum potential energy. Okay. So these hydrogens, they want to be present at this length. Whenever they are present at this length, they are stable. So this 74 picometer distance between these two nuclei, this is called as bond length of that atom. Okay. So how will we show? We will not write all these circles and all. How will we show? In a ray diagram or a block diagram, we will write the hydrogen symbol like this, and we will put a dash and hydrogen symbol like this. The distance between them, this bond length is how much? 74 picometers. This means the nucleus of this hydrogen atom and the nucleus of this hydrogen atom, which came and bonded here, the distance is how much when they are bonding? The distance between them is 74 picometers. I hope you understood. So when they are present at 100 or 200, nearly 200 picometer distance, that is, they are far apart, the potential energy is 0. Now, up till this, we understood what is happening in the graph. As they are coming closer, the potential energy is decreasing. It has reached a minimum value. Now, what happens? Now, when they are coming much more closer, okay, when they are coming much more closer, what will happen? Like, let me draw something like this. A hydrogen atom is something like this. This is a hydrogen atom. This is another hydrogen atom. The internuclear distance, this is the nucleus, this is the nucleus. So, this hydrogen atom started moving towards the Okay, so it started making a bond, and the nucleus internuclear distance is how much? 74 picometer. At this state, the bond is formed and the potential energy of the system is minimum. So this is where the two hydrogen bonds to be present, because they will be highly stable at this position. Okay, now what happens? If you move any closer, what will happen? Now, this internucleus distance, as it is decreasing, the nucleuses are coming much more closer. When the nucleus are coming much more closer, they will repel each other. When they repel each other, the potential energy of the system will again increase. Why? Because there is repulsive forces now. What happens? These both cannot be present less than 74 picometer distance. So they will be repelling each other. Again, the potential energy will increase. So when it is less than 74 picometers, that is somewhere around, let us assume 60 picometers or 50 picometers or 30 picometers. Yes, the potential energy is continuously increasing and is going towards infinity. So whenever they are very close to each other, the potential energy again increases. So our graph will look something like this. Our graph looks like, when they are far apart, the potential energy is zero. So it will be present on this line. As they are coming closer, the potential energy will be decreasing. It will reach a minimum point, and this potential energy is negative. And whatever place it is most minimum, that is called as bond length, which is 74 picometers in case of hydrogen. And from here, again, if you decrease more than 74 picometers, now the nucleus will start to repel. When the nucleus are starting to repel, the potential energy will increase. So the graph will be something like this. I hope you understood this. If you have any doubt, you can ask. We'll see a question out of this that was asked in JEE Mains. The intermolecular potential energy of the molecules A, B, C, D has been given. Okay. And he's asking the following options. Okay. So he has given the potential energy on this side. It is all negative. Okay, fine. Now, first, let us check the first one. D is more electronegative element than other atoms. We should see, whenever there is a more electronegative atom, what it will do, like as we have seen with hydrogen and fluorine, the electrons will be pulled towards fluorine. So the bond length will be lesser. When the bond length is lesser, it should be somewhere around here. Yes, the bond length is 50, 100 and 150. So D is having more than 150. So definitely D is not that electronegative. If D was more electronegative, the bond length should have been small. So this is not correct. Next, AD has the shortest bond length. Obviously, no, AD is having 150 picometers, whereas others are having 100. Some people are having nearly 60 also. AA is having nearly 60. So AD has shortest bond length is also not correct. Then comes AB has a stiffest bond, not bone. This is AB has stiffest bond. Stiffest means the strongest. Yes, AB will have stiffest bond. Why? Because AB is having nearly minus 550. It is present at minus 550 potential energy. So if you want to break a bond, you have to provide that 550 kilojoules energy per mole. So AB is the strongest bond of all, because you can see AA is present somewhere on minus 450. AC is also present nearly same thing. And AD is present nearly minus 350. So which bond is more stronger? That means it is minus 550. That bond is more stronger. So AB bond is more stronger. That is correct. AA bond has got larger bond enthalpy. That is also not correct. Whichever bond is stronger, that bond will have larger bond enthalpy. So this is also not correct. So the option would be C. So this is how the questions will be asked on the graph. I hope you understood. If you have any doubt, you can comment below. Thank you.